then we can break them and we will rearrange them in with respect to their respective orders, right? So we have A naught, B naught. Then if I just add, if I just collect the coefficient of x power 1, then what we will get? So here we have b1x, right? So a1, a naught, b1 is one coefficient of x. Another we can get from here, right? Plus a1, b naught. This is the coefficient of x. Is there any other coefficient of x?
No, ma'am, no.
This is the only coefficient of x, right? Similarly, we can get the coefficient of x squared. So it will be a naught, b2. Then we have
A1, B1,
right. And then from the next term, we will get
A2, B0. A, no, no, no,
b,
B2, A1.
right?
No, 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 no. Yeah, yeah, yeah.
Is it fine?
Yeah, yeah.
Okay. This is the coefficient of x squared. And it will go up to the nth term. So at the nth term, what we will get? A naught, bn, then a1, bn minus 1, and so on, right? Up to a naught, bn, right? This is the coefficient of x power n. And then we will get the rest of the terms. Like if I try to calculate this, so we will basically get an, bm, x power m up to this, right? Is it clear?
Yes, ma'am.
Okay. So if we now just notice the terms, then we can see we can uh, express it in a general form, right? So we have the constant term. So we can express this term as summation I equals 0 to 1 ai b some r, here b1 minus I x power 1, right? Similarly, we can express the second term as I equals 0 to 2 ai b2 minus I x power 2. And we can do this thing with all the terms, right? Can you also find the similarities? Is it fine? We can express this coefficient in this form, right? Is it
Yes,
fine
ma'am.
for all of
Yes,
you?
ma'am.
Okay.
Yes, ma'am.
Then again, we can re-express this thing. So if I just take this as an general R, so we can express it R equals 0 to m summation. Then the coefficients we will take. So I equals 0 to 1 ai bi minus 1 x power r, right? Is it fine? So this is the general formula for multiplication of polynomial. And the thing is, like, you have to, the main thing is you have to multiply all the terms with each other. Okay. So is the general form clear to all of you? Then we can move to an example. Multiply this two. You just multiply and let me know what is the multiplication. Yeah.
What are you discussing today in this session?
What?
What are you discussing today in this session?
It's basically about polynomials. All the basic things about polynomials and graph of polynomials, how to draw the graph of any polynomial, turning points and all. Like
I am
week 4
Can
content.
you explain again of
okay.
above question or answer? I don't know what is this, but kindly explain again, please.
Can you repeat again? I couldn't hear it.
Ma'am, kindly explain again of above solution.
This
What
one,
is yeah, ma'am.
this one multiplication of polynomials.
Yes, ma'am. Yes, ma'am.
Okay, so in which step you have problem?
Ma'am, can you explain again because I came here so that I did not see any
Okay,
text.
so I am just giving you the brief description. You can see the details in the live section. Okay, so let me just describe it briefly. So here we have two polynomials px and qx. Okay,
Right,
represented
right,
by
right.
this two, and we want to do the multiplication of these two polynomials. So for polynomial multiplication, we have to basically multiply each term with each other.
How you
Okay,
get
all
px
the
value
term.
of a naught?
What?
How you get the value of a0 and plus a n to
This is
x ki
this is
power
the
m?
expression. This is the expression of polynomial. This is I'm taking a general polynomial. Okay,
Okay,
where your a naught, a1, and up to an and all the bi, they are basically constant. Okay, and this
okay,
constant are called coefficient. Okay, so this
okay,
is
ma'am.
a
Okay, ma'am.
general
I understood.
polynomial. If
I understood, ma'am.
yeah, particularly you can take any real number, so we will get a real polynomial. Okay, so in
Yes.
order to multiply two polynomials, we have to multiply it term by term. That in the second step we can see with each member of the first
After that,
polynomial
I
we are
can do, ma'am.
multiplying the second polynomial,
After that, I
right?
can do. Just I have a problem in how you get the
Okay,
value.
okay.
Okay, thank
So is
you.
it now fine for you?
Yes, yes.
Okay, okay, good. So this is the example, and you have to multiply these two polynomials and let me know what is the multiplied polynomial. What is the answer you are getting?
X to the power 5, 3 into x to the power 4 plus 2 into x to the power 3 plus 8 into x to the power 2 and 3x.
This is you are getting, right? Okay. So let us do it step by step. So x cube plus 2x plus 1, then multiplied by x square plus 3x, right? So we have to multiply it term by term. So we will get x cube into x square 3x plus 2x, x square plus 3x, then again x square plus 3x, right? So again we will multiply. So we will get x power 5 plus 3x power 4 plus 2x cube plus 6x square plus x square plus 3x, right? So x power 5, 3x power 4 plus 2x cube plus 7x square plus 3. This is answer. Is it fine? It will be 7. Rest of the terms are okay. Is it fine?
Yes, ma'am.
Anyone? Okay. Okay. So
Yes,
next
ma'am.
we have division. Yeah. So next we have division of polynomial. So again, if we have two polynomials px and qx, if I want to divide the polynomial px with the polynomial qx, okay, so sometime we may get a polynomial, sometime it p may not be divisible by q, right? So you have a qx plus rx. In this form, we will get qx. Okay, so here this term is called the quotient. This is the remainder, and this term q is called the divisor, right? Right.
Yes.
So some
Yes, ma'am.
yes. Okay.
Yes, ma'am.
So we can again, yes. Are you asking something?
No, ma'am, it's clear.
Okay. Okay. So we can again rearrange this, and we can also write it as qx, small qx plus rx, where the rx is the remainder. Okay. And this is our divisor, and this is our remainder. Okay. Now we have some facts about the division of polynomial. So p can be divisible by q only if degree of p is greater than
In
degree of q,
yeah.
right? Greater equals to degree of qx, right? So this is a fact we have to keep in our mind. And the second thing is degree of remainder. Degree of the remainder is always strictly less than degree of the divisor, right?
Yes, ma'am.
Right. So these are two notes we have to keep in our. Okay. So let us solve the example. Suppose we have x squared plus 6x plus 9 by x plus 3. This is our px. This is our qx. So what will be the value of the division? What will be the value of the division? Can we divide p by q?
X plus 3.
Yeah, correct. So this is the PS is nothing but x plus 3 whole square, right? And we have x plus 3 the below. So we will get x plus 3. Now, suppose if I have x plus 7x plus 9 by x plus 3. Then we can adjust it and we will get 6x plus 9 plus x by x plus 3, right? So then we can rewrite it as plus x by x plus 3, right? In that case, we will get a remainder, right? So we will get x plus 3 plus x by x plus 3. And if we simplify it, so we will get x squared plus 7x plus 9 equals x plus 3 whole square plus x. So this is our remainder, right? And 1 x plus 3 is our quotient and 1 x plus 3 our divisor. Okay, is it fine?
Yes, ma'am.
Okay, another example we can also do. some, suppose you have plus some 5x plus 6, 5x plus 2. So what is the value? X plus 3.
Madam, last step, how you got remainder as only x, madam? That I am not able to understand.
Which one?
The
This one?
last step. Yeah, yeah. This
This
implies
step?
that, yeah, that one.
Okay. So here we have x plus 3 in the denominator, right? Also here we have x plus 3 in the denominator. So if I just multiply both sides with x plus 3, then this x plus 3 will be cancelled out. This x plus 3 will be cancelled out. This will be twice x plus 2, right?
Yeah, okay,
Ma'am,
madam. That is okay. But why we have to multiply? Because the x square plus. How can
No,
this
no,
x plus?
this is not necessary. This is
No,
not necessary. It is just because. Mhm.
what I am trying to tell is we are dividing p by q. Okay. And we
Yeah,
got one answer, that is x square plus 6x plus, x plus 3 the whole square plus x divided by x plus 3.
yeah,
And then you separated the both parts, that is x plus 3 separately, because x plus 3, 1 x plus 3 will cancel in the numerator. So x plus 3 plus x by x plus 3
yeah,
divided by x plus 3.
yeah,
This will be the
yeah.
final answer, no? Why again? How we are multiplying that by x plus 3 both sides? Why?
Okay. So, see, the above line is the final answer for P by Q. And the last line is the expression of P. That means we can express P in such a way.
Okay, okay. You are expressing
This is
P in
the
such a
final
way.
answer. No issue.
Yeah.
Yeah,
So the
yeah, yeah. We are expressing P in such a way.
P
Okay.
you are
So this is
expressing in the different
basically,
way.
for this we are following the second format. Okay. So P can be expressed in this form. To divisor plus remainder. Okay.
Okay, but that is not
The
required for
second
us.
format.
That is not required, no,
No,
madam.
no, no. This is no, no, no. This is not required. Yeah,
Okay, okay. Thank you.
yeah. Any doubt? Any doubt?
ma'am, the
Okay.
answer
So
is
what
x
is the
plus 2.
value of this?
X plus 2.
So we can factorize the above equation, right? X squared plus 2x plus 3x plus 6 by
Hello, ma'am. I'm not heard your voice. Hello. Hello.
Anyone able to hear me?
Yes, yes.
But madam, I
Yes.
think she is not there,
Not
no?
audible. Yeah, yeah.
But whether she is there in the participants?
Hello,
I think
am I
Yeah,
audible?
yeah, she came, she came.
yes, ma'am. Yes, ma'am.
Okay, okay. I just my network got disconnected. Can you see the screen now?
Yeah.
Ma'am.
Yes, ma'am.
So how much did you learn?
No, on
Yes,
all
and
the
behavior.
no. Last was x plus 2 only one. X square plus
This one.
5x plus 6. No, we just solved that. This
This
question we
one.
solved, madam. Yeah, we
Okay,
solved
okay,
this
okay.
x
Okay,
plus
okay, fine.
2.
I will cover it again. Yeah, okay. So, end behavior means when we know that if I have a function, so while drawing a graph, we generally take the x-axis as our domain and the y-axis as our codomain, right? So when x is tending to infinity means we will move towards the positive x-axis. up to infinity, right? And if we are moving towards the negative x-axis, means x is tending to minus infinity, right? And end behavior means basically we have to check the behavior of the function when our point, when our domain, when we're taking the end point of the domain, right? Is it clear? Is it clear?
Yes, madam. Yes, madam. End point of the domain, that is, will go minus infinity or plus infinity in x side.
Yeah. So, so when we are talking about polynomials, then so for any polynomials, our domain is basically real number. That means end point will be positive infinity and negative infinity, right? So if I have a polynomial and if I ask to check the end behavior of a polynomial, so we will check at the positive infinity and at the negative infinity. Okay. So if at the positive infinity, if the end behavior of the polynomial is in the upward direction, this is the positive y-axis, right? So if it is in the upward direction, that means the function is going to infinity. And if it is in the downward direction, that means the function is going to minus infinity, right? Because in downward direction, we have the negative y-axis. That means towards the downward direction, we hold the negative y infinity, right? Is it clear?
Yes, ma'am.
Okay. So then we have example.
Ma'am,
We
I'm
have
not able to
polynomial
hear you
x cube.
properly.
What?
Ma'am, your voice is
Ma'am,
still cracking.
yes, ma'am, I'm not able to hear you properly, so I couldn't understand it.
Now can you hear? Now am I audible?
Yes, ma'am.
Okay. So what I was saying is, when the function, when the function graph is going in the upward direction, it is to infinity, and when the function is going to the downward direction, that means it is going to the negative infinity. This is what we know. Okay. So this is the example x cube plus 2x plus 1. So we have to check the end behavior for the function. So when x is into infinity, how will the function behave?
Infinitive.
Infinity, right? And if x is tending to the negative infinity, then how will the function behave?
Negative infinity.
Right. So basically, we have to check the highest power. Okay. So let me write. Polynomial. We have to check the highest degree term, that is whether it is odd or even, and its coefficient.
Basically, check that a n x to the power n.
That is a or n. So this thing we have to check. You can see the screen, right?
Yes, ma'am.
Yeah. Okay. So our example is like minus x square plus plus x plus 1. How will the behave? So if x is tending to infinity, then what will be the behavior of px? We
Ma'am,
will
I'm
check
not.
the highest order.
Your voice is cracking and
Yes.
the screen will be stacking out.
Can you see it now?
Yeah.
So yeah, can you see this example px minus x square plus x plus 1?
When extended to infinity, p of x tending to minus infinity.
Yeah. And
Both
when x is
minus
tending to
square.
minus infinity,
X tends to
yeah,
p
minus
of
x
p of
Both
square.
are,
yeah
Yeah,
plus infinitive.
right?
No, minus infinity. Yeah.
both are minus infinity
Both
because
are
Minus
both
what
are
is
minus.
infinity,
initiation?
right? So we have to, both are minus because the coefficient is minus and the power is positive, right? So from the x square, we will always get a positive infinity. And if I take a negative, so we will always get a negative infinity, right? And if I have px equals to minus 3x power 5 plus x power 4 plus x cube, then
P of
Again,
x tend.
endpoints
what
will be
will be
similar
the,
to x cube only, plus infinity minus infinity.
so what will be the value? Like if x is tending to infinity, then
Minus infinity.
Minus infinity.
sure. Yeah.
Yeah.
X is tending to infinity, x power
Yeah.
5 will also tend to infinity. So minus
Yes.
sign is there. It will go to minus infinity.
Correct. Correct. So it will go to infinity if I take
Yeah.
minus infinity, right?
Yeah.
Okay. Okay. So n behavior is clear to all of you, right? So we can now move to the graph. So we have rules. If the we can factor, like if I have the polynomial px equals and if some alpha 1 alpha 2 dot alpha r, suppose these are the roots of the polynomial, okay, and we know that roots means x intercept, right?
Yes, ma'am.
Yeah, or x intercepts. So then we can express the polynomial px in such a way. Some I1, some I2, x minus alpha r, some IR. So this I1, I2, dot, these are basically repetitions of the root, right? So equated with 0, we will get alpha 1 as a root I1 times, alpha 2 as a root I2 times. So these are basically repetitions, right?
Yes, ma'am.
I1 is repetition of alpha 1, IR is repetition of alpha r, and so on, right? So if I have any polynomial, and once we know the root of the polynomial, we can express the polynomial in this form. So we can basically factorize this polynomial. Okay. So if the exponent of the factor, now exponent of the factor, okay, and here we will see the graph, okay. Yeah. So if the exponent is linear, that means 1, okay. then we will get the, suppose this is our alpha 1 and suppose I1 is equals to 1. That means the repetition of alpha 1 is 1. Then we will get the graph like that. That means it will just cut the x-axis at the root, at the point. Okay. So if I get any even degree, that means in the format 2n, suppose for example, our I1 is equals to 2, then at that point we will get, suppose this is our alpha 1. So because I1 is repetition of alpha 1, so we will get the graph like that. Okay. So that means if I have the degree, the exponent as something even, then we will get a U type of shape. Okay, it can be in the upward direction, it can be in the downward direction. So the direction will determine by the end behavior, but at the root it will be in a U shape. Okay, is it fine?
Yes, ma'am. Yes, ma'am.
Yes,
Yeah.
ma'am.
And if it is odd, if we have a odd degree, that means 2n plus 1 format, that means 3, like accept 1, odd degree greater than 1. Okay, 3, 5 and so on. So for example, if I have I1 equals to 3, okay, so at the point alpha 1, we will get this type of graph or this type of graph. Okay, so this is the thing. If I have a linear exponent, then the line will just pass at that point. Just cut the x-axis at the point. If I have some even, then we will get a U type of shape at the x-axis at the point. And if I have odd degree, then we will get this type of shape at the point. Okay. So we can now solve some examples. So again, if I have this example, x cube, x squared plus 5x plus 6. Okay. So let us try to draw the graph of this polynomial. So we will break it in 3 steps. Okay. So step 1 is we have to check the end behavior first. So how will be the end behave? If x is tending to infinity, then what is the behavior of px?
Plus infinity.
Yeah. And if x is tending to negative infinity, then
also
Plus infinity.
plus.
Also plus infinity.
okay. And then in step 2, we have to find the roots. That means we have to factorize the equation. So what will be the factorization?
2 and 3. X
Yeah.
plus 2 and x minus x plus 2. 3.
This is the factorization, right? That means roots are minus 2 and minus 3, right? That means at the point minus 2 and at the point minus 3, it will cut the x-axis, right? So roots means x-intercept, okay? And third thing we have to check, y-intercept, right? So what is the y-intercept? Y-intercept means
6.
we will equate x with 0. So p of 0 is the y-intercept, which is 6. So these three things are enough to draw the graph of a polynomial, right? So step 1, we will try to follow step 1. That means when x is tending to infinity, our function is tending to positive infinity. That means the graph will go in the upward direction here and also here. Is it fine?
Yes,
Now,
ma'am.
yeah, we have minus 3 and minus 2 as our root. So because the exponent are 1 and 1, so it will just cut. It will just cut the point, right? Like that, right? Is it fine up to now?
Yes, ma'am.
Yeah. Now we have to join this end and this end, right? So to join this, we will get a y-intercept, and this y-intercept is nothing but 6, right? That means this length is 6. Okay, that is how we can draw the graph of a polynomial in these 3 steps. So is it clear to all of you, these 3 steps?
Yes, madam. Madam, but instead of drawing the n behavior first, because this is basically misleading, it will become like we can go to step 2, step 3, then step 1, no?
No. In that case, I guess you may face some like ambiguity, because if I go to step 2 first, okay, so we don't know whether it will go from this to this or this to this, right? So there will be a confusion in that case, right?
No, but step 1, after step 2, we know that it will go plus infinity, no? Obviously.
Yeah, that is the end behavior, na? Because you
Ye-
know it will go to plus infinity. So this is what you are analyzing, the end behavior, right?
Yes, madam.
Yeah.
No, no, why I told is, see, after 6, your graph is coming down, no? So that's why I'm telling.
No,
After
no,
why?
that is not a problem. Here we are just focusing on the roots. Okay. So
Okay,
it
okay.
will not be in the downward direction. It may be in the downward direction. So it can be like that. So this is not a issue. Okay.
Okay, madam. Okay.
Yeah. So the basic thing is the roots, the graph will cut at the roots, and the picture near roots, like here, and the end, like both the end is going towards the upward direction, like that. Okay. Okay. So let us solve one more example. Suppose we have px equals to suppose this is our polynomial. Okay. So let us do our step 1. So what will be the end behavior when x is tending to infinity? What will be the behavior of px?
Infinity.
Okay. So for all, I'm just repeating it. How can we check that? We will check it factor by factor. Okay. So if x is tending to infinity, that means x plus 2 will be tending to infinity, right? X minus 3 will be tending to infinity, and its cube also will be tending to infinity. And x plus 5 square is also tending to infinity, right? Now px is just multiplication of these two. So it is just infinity into infinity into infinity. That means px is also tending to infinity, right? Similarly, what if x tending to minus infinity? Similarly, you have to analyze all the factor and you can
P of x tends to infinity.
So also it is also we can check. So if x is tending to minus infinity, then x plus 2 will be tending to minus infinity, right? And x minus 3 cube also will be tending to minus infinity, and x plus 5 square will be tending to positive infinity because of the even term, right? So px will be then tending to multiplication of all this infinity. So minus infinity into minus infinity into infinity, that means infinity, right? So this is how we can check the end behavior. So now we have the roots.
No, but the professor was telling like you take the highest
Yeah, that is
power of
also you
x.
can do. That is also you can do. So you
When we
can
multiply
multiply.
this thing,
Yeah,
yeah,
you can multiply these factors and you can calculate the highest term, and then you can just check the highest degree. This is another way and this is another way. Okay, so
Yeah.
you have two different ways. Whatever is fine for you, you can choose any one of them. Okay.
Okay, madam.
Yeah.
Now we are in the certain step where I mean you are going step by step because always will not be able to expect to get the expression in this form, no, madam?
Yeah.
Like you already factorized it.
Yeah. So if
Oh.
if you don't have anything in the factorization form, like the first problem, you have to factorize it. And if you have in this form, then it's fine. Okay.
So for our syllabus, for this particular case, factors will be given to us.
Yeah. Maximum time, if it is something difficult, then factors will be given to you. And if it is simple, like the first example, then you can factorize it easily, right?
Yeah, that's okay, madam.
Yeah. So we have in the second step, we have roots, right? So the roots are 5 with even multiplicity. Then we have 3 with odd multiplicity. And we have -2 with linear, right? And what is the step 3? We have to calculate the y-intercept, right? What is the y-intercept?
Okay, 5
Zero.
5 are 25. No, 0.
Okay. No.
This, right? So what is the final thing? This will be some constant, right?
27 into 2, 54 into 25. Yeah, some constant. See,
Yes, some constant c. Okay.
Yeah.
So now we can
positive.
draw the,
It will be negative constant.
yeah, some negative constant.
Yeah.
That means the graph will cut the negative y-axis below the origin, right?
That is important. Whatever it's positive or negative is very important because then only the graph will
Yeah.
can
Yes.
draw properly.
Yeah. So we can first draw the roots. So these are the roots. Now we have the end behavior. That means both the end will be tending to positive infinity. That means in the upward direction, right? So near -5 we have even. That means we will get a u. This end is in the upward direction. That means we will get the u in this upward side, right? Then we have -2 with linear. So we will get this. So we can join this two. We will get this. Then it will cut the y-axis in negative side. This is our -c. Then we have c with odd. That means we will go like that. Then we will join this two ends. Okay. Is it fine?
Yes, ma'am. Yeah.
Okay. Any doubt?
No, ma'am. No.
Okay. So next thing we have turning points. So turning points is clear from the name, right? So when the graph is turning, that means it is going in the upward direction and suddenly it turned back and it is going to the downward direction. So this is one turning point, right? Another we can see if it is going downward and suddenly it is going upward, then this is another turning point, right? So whenever we are taking a point as a considering a point as a turning point, that means we will get a U shape at that point, correct?
Yeah,
So
either
if
it
I
can be
see
U
this
shape.
graph,
No, in the above example 3, you are getting that saddle, no, madam. It's not U actually.
no, it's not U. It's like that.
So it is
Like
not a turning point there. Then.
no, it is not a turning point. Yeah.
Okay.
So you have to get a proper U shape like
There
that.
is change of direction.
This, yeah, change of direction. That means whether it will be increasing to decreasing at that point or it will be decreasing to increasing at that point.
Okay. So when I equal to odd numbers more than 1, that is not a turning point.
At
It's
that
only
point,
just
yeah,
in
at that
the
point you will
yeah.
not get a turning
If
point.
it is increasing, it will keep on increasing only. Only it is cross that x axis. That's all.
Yeah. Yes.
Okay, madam.
So then for this curve, how many turning points are there? Then how many U shape are you are getting?
3.
3, right? This is the first one, this is the second one, and this is the third one, right?
Okay, ma'am.
Okay. So this is the 3 U shapes you are getting. What about the previous graph? This one? 1, right? Only this one, right? So one turning point is. So if I have this type of graph like this, then the number of turning point
4.
1, 2, 3, and 4, right? Okay, so it is now clear. Now the last thing is, we know if I have the like equation of a polynomial, then we can draw the graph, right? But we can do it like from the opposite side too. That means if I have the graph of a polynomial and the roots, then we can find the equation of the polynomials too. Okay, graph to equation. So we just have to do the same thing, but from the opposite direction. That means once you have this, suppose this is our polynomial, okay? Suppose this is our polynomial. This is our x-axis. This is our y-axis, okay? Suppose this point is -5. This is 2, -2. This is 1, and this is 4. And this point is, suppose, some 2, for just for consideration. Okay. Now, just seeing the graph, we can do the same steps, right? So what is the y-intercept? We have the y-intercept as 2. Roots. What are the roots?
-5,
What are the
Minus
roots?
-2,
5, -2, 1, 4.
1, 4.
These are the roots, right? And what is the end behavior?
Minus infinity, it will go towards, if the x tends to minus infinity, we are going to plus infinity. And when it is plus infinity, it is minus infinity.
This is the end behavior, right? Now we have to form the equation. So we will first generalize it. We have to take a constant and we will find the value of the constant. Okay. Then we have the roots. That means we will get the exact factors, right? X plus 5, x plus 2, x minus 1, and x minus 4. Right? These are the factors. Now, what will be the coefficients?
It's -2 now.
Madam, power also is required. Okay.
-2.
Yeah, power required. That is why I am asking. So first we will get 1. We can determine the power after seeing the picture, right?
Yeah. Crossing -5, it is crossing. So 1.
Yeah.
Again, -2 also, it is like a linear function 1. Then
At
here
1,
it is U shape. So it will be even
something.
numbers.
So we will take the least one. Okay.
Okay.
Least
Why is
possible
that,
number.
madam? Why least one?
Just for simplicity. Okay.
Okay.
So we will take the least power.
And 4 will be odd more than 1.
That means 3, right?
Okay,
Is it
so
fine?
this graph can have many different type of polynomials then.
Yeah. So we can have different type of pictures, and you can equate, like you can calculate the exact equation of the polynomial after seeing the picture. Okay.
Madam, no, but this particular graph which you have given, this also will be having different types of polynomials, no? It is not necessary x minus 1 factor, x minus 1. The power can be only 2, it can be 4, 6, 8, 10, anything it can be
Yeah.
covered.
It can be
So,
anything, but
this,
we will always consider the least one for
yeah,
simplicity. Okay.
we will consider least, madam, no problem. My question is, given a graph, there are n number of solutions for that.
Yeah. Like
Okay.
infinity number of solution. You can take any even number here. So it
Yeah.
depends upon the flatter, like the number whenever we are increasing the exponent. That means if I have the exponent as 2, we will get this type of u. If I have the exponent 4, we will get a more flatter u. then if it is 6, then we will get again more flatter u. Okay. So
Yeah,
it
yeah.
will be more flatter at that point when we are increasing the exponent, and same for the odd power also. Okay.
Okay, okay, okay.
So because in the picture, basically we will get this u, the least shaped u. So we will take the least power for simplicity. Okay. And same for the odd one also. Okay. Now we
Okay.
have to calculate the value of the constant a, right? And for that we have n behavior and our y-intercept, right? So y-intercept is 2, means p of 0 is equals to 2, right? Right?
Yes,
So if
ma'am.
I take p of 0, then we will get a into 5 into 2 into 1 into minus 4 cube equals to 2, right? From here we can find the value of a. So what is the value of a?
So 16 fours are 40, 54.
What will be the final value of a?
minus 1 by
320.
minus 1 by 640.
640.
Yeah.
64 into 5 is by 2 if you do no. 4 fours are 16, 16 fours are
Okay, okay,
64.
okay.
64
Okay,
into 10
320.
is 640.
320,
64
320.
10, 5 means 320.
Is it fine? So
Yes, ma'am,
now
yes.
we have the value of 3 also. So we have the final polynomial, right? So this is minus 1 by 320 into x plus 5, x plus 2, x minus 1 square, and x minus 4 cube. Now we can verify it by the end behavior also, right? So from here we can check the end behavior. So when x is tending to infinity, what are you getting? What are you getting?
1, 2, 2 plus 2, 4 plus 3, 7. 7 means odd degree.
Degree.
So, and minus you are having
Minus infinity.
plus. When it is minus extends to minus infinity, it will be plus infinity.
Plus
So it is
infinity.
verified, right? So it is
Yeah.
correct. And
Yes,
this is
ma'am.
also correct, right? You can check it from here. Is it fine?
Yes, madam.
Yes, ma'am.
Yeah. So in
Madam,
this
what is the
way,
importance of turning points, which you explained just previously?
this one,
Yeah, turning points. No,
importance means what are you trying to say?
no,
So
no.
see,
You
we can
explained the turning
extend.
points, no?
Yes.
So I'm just asking, by knowing the turning points, can we infer anything?
Yeah. So turning points are basically locally maxima or minima. Like sometimes you may have to find the maxima, minima, local maxima, minima for a function. So turning points are local maxima or sometimes local minima. And we can also extend the concept of turning point to critical points. Then we can observe the local minima and maxima with the second derivative test. Okay.
Okay, okay.
Yeah. Okay. Any doubt in this graph to equation? No, right? So I will give you one example and you have to compute the graph and let me know. Okay. So this is the graph. I'm waiting for 5 minutes. You just calculate the equation and let me know what are you getting. Then we will solve it together. Anyone? Are you solving it?
X plus 2,
Mm-hmm.
x plus 2 the whole square into x plus 1
X
the
plus 2.
whole square
Mm-hmm.
into x plus 1 the whole cube
X plus 1 whole cube.
into x minus 1
X minus 1.
into x minus 2
Mm-hmm.
into x minus 4,
Mm-hmm.
and the value of a is 32 by 3.
A equals
32 by 3.
32 by
3, 3.
3. This one?
It's,
Is it okay?
yeah.
Okay. Okay, so let us do it step by step. So end behavior we know, if x is tending to infinity, we have our equation is tending to infinity, and if x is tending to negative infinity, we have our equation is tending to infinity. This is our step 1. Step 2, roots with multiplicity. So roots we have -2 with even, then -1 with odd, then we have 1, 2, and 4 with linear, right? So we can then write the example as px is equals to a some constant into x plus 2 squared, x plus 1 cubed, x minus 1, x minus 2, and x minus 4. Now our task is to find the value of the constant a. For that, we will use the y-intercept, right? So what is the y-intercept? It is equals to -3. That means we have p of 0 is equals to -3, right? That means we have a into 2 squared into 1 cube minus 1 minus 2 minus 4 is equals to -3, right? So we will get a is equals to -3 by 4 into 2 into -4, right? That means 3 by 32. It's 3 by 32, right?
3 by 30.
Yeah, 3 by 32. So we have the final polynomial as px equals to 3 by 32 into this multiplication, right? I'm taking it as some qx and 3 by 2 is into qx. Okay, is it fine for all of you?
Yes, ma'am.
Okay. And what is the number of turning points here?
Ma'am, 4.
Okay.
4, ma'am.
So we have 1, 2,
Okay, 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 okay.
3,
4,
4,
5,
and
5,
5
5.
turning points, right? Okay. So, and what is the maximum degree?
Sorry, it's
What is the maximum degree of the polynomial?
10.
no, it should be a
10.
infinite polynomial.
So it's 2 plus 3 plus 1 plus 1 plus 1, right?
8, 8, 8.
8.
8, ma'am. 8, 8.
Right? So this is the maximum degree. And what was the maximum degree of this equation? After seeing the graph also you can say, right? You just have to check the roots and the picture near the root. So from here we will get 1, from here we will get 1, from here we will get 2, and from here we will get 3, right? So the maximum degree will be 3 plus 2 plus 1 plus 1, right? 7. Any doubt? Anyone? Any doubt? Is it fine to all of you, right? It's okay
Ma'am,
for all of you, right? Yeah.
ma'am, in the last, can't we take in, the upward direction? In this graph, can't we take the, where you have taken the 3 as the degree, can't we take 5?
Yeah, we can take 5, but we can take any odd degree, but whenever the degree will be increasing, then this will be more flatter near that point, like that. Okay. So whenever you are asking to do this type of thing, that means you have a graph and you have to calculate the least degree. So you have to take the least number possible. Okay. Least possible number you have to consider. Okay.
Okay.
Yeah. You can take any odd degree, but in order to avoid the ambiguity, we will take the least one. Okay.
Least.
That means we are just we're trying to get the approximate thing. Okay.
Okay.
Yeah. Any other doubt? Okay. Then we have one property, intermediate value property, or IVP. So it says that in the domain, if I have 2 points A comma B in the domain, such that P of A into P of B is negative, then there is some C in between A and B. That means C is just considered this. So C is less equals to A and greater equals to A and less equals to B. Then there exists that C such that P of C is equals to 0. This is our intermediate value property, right? So why is it so? I mean, if I have a polynomial, that means polynomial is a continuous function, right? We cannot, we have to draw a polynomial function with a single drag of our pencil, right? So whenever we have a PA, PB, multiplication of this to negative, that means either PA is negative, PB is positive, or PA is positive and PB is negative, right? Right?
Yes, ma'am.
Yeah. So whether we will get this PA, PB, this type of picture, or we will get this type of picture. This is our PA, this is our PB. So in any case, we can see the line will always cut the x-axis, and that this point is basically our C, right? Here our P of C is equals to 0. So this is the intermediate value property. So this is true for polynomials, and actually this is true for any continuous function. Okay, any continuous function, and particularly polynomials are continuous function. So it is true for polynomials. Okay.
I have a doubt.
Yeah.
You
Can you
said
be little louder? I cannot hear you properly. Actually.
you told that P of C is equal to 0 in case of intermediate value property.
Can you tell it again?
You told that P of C is equal to 0 in case of by using this property IVP.
P of C is equals to 0 in case of
IVP, that is by using this property.
Yeah, so we will always get a C such that P of C is 0. Like, and the C is in between A and B.
Actually, it should cut the y-axis, no? P of C is equal to 0 means the function.
No, it will cut the x-axis. See, it will cut the x-axis. P of C is equals to 0. That means y-axis is 0, right? Y coordinate is 0, right? So the point on the graph will be c comma p of c, right?
Okay.
So p of c is the y coordinate, that is
So,
c comma 0, right? So this point is our c comma 0 point.
yeah. So it
Okay.
must be the one of the x-intercepts.
Yeah. This is the one of the x-intercept. Yeah.
Thank you.
Yeah. Okay. Any other doubt? This was the week 4 content, right? We don't have anything other than these things, right?
Yes.
Okay. So yeah, now you have any conceptual doubt, you can ask me. I will try to cover it. Anything? Anything do you want to ask?
Ma'am, I have a doubt in the end behavior concept. Can you tell
Okay.
me?
Okay. So what is your particular doubt? Just tell me, then I will repeat it.
So I'm not getting actually the x. If x is infinity and f of x is infinity, the concept behind it I'm not getting actually.
Okay. So graphically, is it fine, or graphically you are confused?
Both the things, ma'am.
Okay. So let us first do it graphically. That means when x is tending to infinity, that means we will take x in this side, right? Towards the positive x-axis.
Positive.
Right?
Yes.
And if y is also, that means the value of p, if it is also tending to infinity, when x is tending to infinity, then when x is tending to infinity, this will go to the upward direction, like that. If px is tending to infinity, and if px is tending to minus infinity, when x is tending to infinity, then our graph will go in the downward direction. So we can see the movement, right? Here we can see the x value is going to infinity, x value is going to infinity, but the y value is going to minus infinity, right?
Yes.
Similarly, when x is going to negative infinity, if the graph is going to positive infinity, that means it will be going to the upward direction. And similarly, if it is negative, then it will be going to the downward direction. So whenever the graph is something positive, that means the value of y-axis is positive, it will be going to the upward direction. And when it is in the when it is going to minus infinity, it will be going to the downward direction. Okay, this is the main thing.
Okay.
And if you have a polynomial, suppose our general polynomial, okay, an x power n plus a n minus 1 x power n minus 1 up to the constant term, then you have to, if you have to check the n behavior extend to infinity, it is enough to check the n behavior of this term, the highest degree term with its coefficient. Okay, so like when x is tending to infinity and power, that means n, and coefficient, that means n. So if n is positive and the power is also even, so we will get the polynomial px will be tending to what? Even means we will get positive infinity from here, right? And the coefficient is positive, that means we will get positive infinity, right? Positive infinity, right? Yeah. If the coefficient is negative and the power is even, then we will get a negative infinity. Okay, negative, positive, negative. Okay.
Okay.
Yeah. Similarly, if the coefficient is positive but the power is odd, but because we have x is tending to infinity, so it doesn't matter whether the power is even or odd, we will always get x power, that power will be tending to infinity, right? And it is multiplied with this term, then it is tending to infinity. And if we have negative with odd power, then we will again have negative infinity. Okay. This is for positive infinity. And if x is tending to negative infinity, and if we have the coefficient as positive and power as some even, so negative will be positive when the power is even, right? That means if x is tending to negative infinity, so x power 2 will be tending to a positive infinity. Or x power 4 also will be positive infinity, right? Right? And we are multiplying this positive infinity with some positive term. That means in result, we will get a positive infinity, right?
Yes.
Similarly, if I have the positive exponent with odd power, so negative infinity and odd power, that means we will get a negative infinity and multiply with a positive number. That means we will get a what?
Negative.
Negative infinity, correct. What if we have the exponent as negative and power as even? Then tell me, just try.
Plus,
Ma'am, the n tends to infinity.
positive infinity.
Just the n tends to infinity in the table. The positive coefficient and odd power will tend to minus infinity only, no? The third row.
No, we are taking x tending to positive infinity.
Positive.
So power doesn't matter.
Okay. I understood now. Okay. Okay. Yeah, got it. Sorry, I thought it was negative. Okay.
No, yeah, it will be positive. Okay. So when the coefficient is negative and power is even, then what will be the n
Positive.
So we will get is, because it is even, it will be negative, right? Because it is even, so we will get x power, that power as a positive infinity multiplied with the negative coefficient.
Negative.
So we will get a negative infinity, right?
Okay.
And if we have the negative coefficient with odd power, then we will get negative from here and negative from here. So negative will be positive then, right?
Positive. Yes.
So you can just analyze this chart and we will always follow this chart. Okay.
Okay, ma'am.
Any other doubts? Anything else?
I have a doubt regarding angles between two lines.
What?
We have two formulas. This one is for acute angle and another one is for obtuse angle.
I can't hear you properly. Can you be little louder?
Ma'am, can you give me one exam? Can you show me the one graph so that in
Okay. So in this graph, you can see when x is tending to infinity, the polynomial is tending to towards the upperward side, right? That means x is tending to infinity.
positive.
It will be tending to positive infinity. And also when x is tending to minus infinity, the graph is going to the upperward side. That means it will be again positive infinity. So this is the end behavior, right?
Okay, ma'am.
Similarly,
In
for
this
this
way
graph,
only we will decide.
yeah. After seeing the graph, you can decide. Similarly, for this example, when x is tending to infinity, the graph is tending towards the downward direction, right? That means when x is tending to infinity, graph will be tending to minus infinity. That means this second line, right? And when x is tending to negative infinity, the graph is tending to positive infinity. That means in the upward direction. That's the first line, right?
First line. Yes, I understand, ma'am. Thank you.
Okay. Yeah. Anything else?
Ma'am, to find the angle between two lines.
Find the angle between two lines.
Two lines. There are two formulas. One is m2 minus m1 by 1 plus m1 m2. Another one is m1 minus m2 divided by 1 plus m1 m2. So if they ask if they ask what is the angle between two lines, which formula we should use, ma'am?
So naturally we will take the anti-clockwise direction. That means a positive value. Okay. So you have to take the positive value.
Okay. So the value should be the positive one.
Yeah.
So we have to use accordingly the formula.
Yeah. Yes.
Okay.
Yeah. Anything else? If you have doubt, you can ask. Otherwise, we will end the session. Like if you don't have doubt, you can leave. Otherwise, ask. I'm waiting.
Just give one more refresher, madam. IVP.
Haha, IVP. Yes.
Yeah, can you explain once more, please, if you don't mind?
Yeah. No. Never. Why I will mind? This is my job.
Okay, madam.
Okay, so IVP basically says if I have 2 points in our domain A and B, and we are taking that A is less than B, okay, and if the multiplication of these two, that means the functional value of A and functional value is B is negative, then there will be a point in this interval, like that means this, actually this, such that the functional value of that point is 0. That means at that point we will get a root. That means x-intercept, right? And why is it so? If we have this condition, right? PA into PB is less than 0. That means 1 is negative. Like multiplication of two numbers is less than 0. That means one number is negative and one number is positive, right? So we have two different options. First option is P of A can be negative and P of B can be positive. And the second option is P of A can be positive and P of A, B can be negative. These two are the choices, right?
But
So yeah.
you are telling no, P of A is less than P of B.
No. I told you that A is less than B.
Yeah, A is less than, okay, A is less than B.
It will not mean that P of A is less than P
Less
of
than,
B.
correct, madam.
So
Okay,
we can have monotonically increasing and decreasing function too, right?
correct,
If
madam. I
yeah,
understood now. Yeah, tell me, madam. Go ahead.
right? Yeah. So we can get both the cases. So if for the first case we will get this type of picture, right? Where P of A is negative and P of B is positive,
Yes, ma'am.
right? And also we can get this type of the second type of picture where P of A is positive and P of B is negative, right?
Yes,
So in
ma'am.
both the cases, we can see that the graph will cut the x-axis at least at one point, right?
Yes, ma'am.
Yeah, and the point will definitely will lie in the interval AB, right? It will be always in between A and B, right? That means we will get a x-intercept. So basically, we have the general version of IVP. IVP is true for any continuous function, okay? And polynomials function are a particular case of continuous function. So all polynomial functions are continuous function. That means we can draw any polynomial function without lifting our pen. Like we can draw the polynomial function with a single drag of our pen, okay? So any polynomial function is continuous function. So IVP property will hold for the polynomial functions too.
Okay. So this concept is discussed now because we are just proving that all polynomials
Yeah.
will be a continuous graph.
Yeah.
So,
So
okay.
you will learn about limit, continuity, and differentiability in your coming weeks. Okay. So all polynomial functions are basically limit for like continuous and also differentiable at any point. Okay.
Okay. Thank you.
Differentiable means?
Yeah, so it is a huge concept. You will learn about this concept in your week 8. Okay.
Ma'am, can you explain multiplicity?
Okay. Multiplicity means basically repetitions, That means the number of repetitions. So that means suppose if I have x squared plus 4x plus 4. So this is basically x plus 2 whole square, right? So the roots are -2 comma -2. That means we are getting -2 but
Twice.
2 times. That means the multiplicity of -2 is 2. Okay. Multiplicity means the number of times the root is getting repeated. Okay.
Okay.
Similarly, if I have this polynomial, suppose 2, then x minus 1 cube, then x minus 4 squared. So suppose this is our polynomial. So we have roots are 4, 1 and -2, right? And the repetition of 4 is 2 times. That means the multiplicity of 4 is 2. 1 is 3 times. That means the multiplicity of 1 is 3 and multiplicity of -2 is 1. Okay. Is it clear?
Yes, ma'am. Thank you.
Yeah. Anything else?
I have
And
a
what
doubt.
about
Graded assignment week 3.
Graded assignment week 3. Okay, so if you have problem related doubt, then we will solve it in the next session. In this session, let us focus on basically concepts. Okay.
Ma'am, even multiplicity and odd multiplicity. What is the difference between both?
powers?
Even multiplicity means power will be even, and odd multiplicity means power will be odd. So here 4 is with even multiplicity, 1 is with odd multiplicity. That's the thing.
Okay.
Okay. Anything else?
And what about tomorrow's session, ma'am? It's on week 5
Tomorrow?
content.
No. Tomorrow we have the solve with us session for week 4.
Okay.
And you can ask your doubts after the. We will solve some selected problem, and after the end, like by the end of the class, you can ask your doubts. Then we will have a open session too, so that you can properly solve all the activity and practice assignment. Then you can ask your doubts.
Okay. Thank you.
Yeah, welcome. Okay, so yeah, if you have any other doubt, you just ask. Otherwise, you can also leave.
In lectures, even multiplicity is also related with the tangent, and odd multiplicity with the y-intercept. How all the things related? Can you explain?
Tell me again. Even multiplicity.
Even multiplicity is like tangent.
Even multiplicity is like tangent. Means?
In the lecture, they've told that in case of even multiplicity, the y-axis will act like a tangent to the curve. I think he's asking about that.
No, not the
In
y-axis.
case of the x-axis.
Yeah.
X-axis.
Touches the x-axis. When tangent touches the x-axis.
Yeah. So basically, whenever you will get a root, and if I have even multiplicity, and the tangent is like at some point, tangent means the line will touch the curve at that point, right? So even multiplicity means we will get this type of picture or this type of picture, right? So at that point, if I want to draw the tangent, so it will be the line which catches the graph, right? So this line will always be parallel to the x-axis. Okay. So if I have even multiplicity of some root, that means at that point, we will get the tangent of the graph as parallel to the x-axis. Not always exactly x-axis, as okay, it will be exactly x-axis, sorry, because it is root, right? So this is, if this is our x-axis, we will get this picture. So our x-axis will be the tangent at that point. Is it clear?
Yes, ma'am.
Yeah.
And if it is odd,
If it is odd, then again same.
That's the x-axis.
Again, it's the x-axis, right? If it is odd, then also the
it crosses the
x-axis is the
x-axis.
tangent. Yeah,
It crosses.
but
Yeah.
yeah. So if I draw the tangent line, it will be the x-axis only. So the x-axis is the tangent at that point. Tangent can cut the graph. There is no issue in it. Okay. Is it fine?
Yeah, fine. Thank you.
Okay. Anything else?
Thank you for the session, madam. It was really good.
Okay.
Thank you and good night, madam.
From the graded assignment doubt will solve in the next session.
So graded assignment 3 or what?
Week 3.
Okay, okay. By the end of the session, you just ask me the questions. I will solve it. Okay. I will try to solve it.
Okay. Thank you.
Okay. Okay, so if you have any other doubt, you can ask. Otherwise, tomorrow we will have the solve with the session. Okay. Okay. So I hope you don't have any other doubts. So
Hello.
yeah. Yes.
Madam, this is not related to any conceptual doubts.
Mm-hmm.
So this is related to the process of a qualifier based foundation to BS and direct diploma to BS.
Okay, so this type of thing, I'm like not very known to this thing. So you can ask someone else about this thing. Okay.
No, TAs are not able to answer, madam. So that is the issue.
Okay, so
Just a simple doubt alone, actually. It is not anything related to the process or anything. I just want to know, will there be the session that will be conducted by you or the team, madam, during the direct diploma too? Like this, how you are hand-holding people to, do well in the exam. Like that, it will be in direct to diploma also.
Okay, but no, I'm not very sure about it. One thing you can do, you just mail the support team about
No,
it.
tried,
Or
madam. Tried. Actually, they are not understanding the.
okay.
Yeah, you see, actually, the thing is that in qualifier from foundation to BS, you
Mm-hmm.
are handholding people with each and every weeks. Like you teach them, you give them assignments, like you make them to, do the exam properly, and I mean, teach them from the scratch. But for direct to diploma, because one of my sister is gonna join now, so now
Okay.
the session is open, so I thought that maybe you can just tell
I
me.
guess their instructor is there in all the courses and all the structures, whatever I know. But you are also attending another classes now, so you can also ask about it in another classes. So
Acha, but
whatever I know,
are you taking, madam? Are you taking any direct to diploma, helping them
no,
to?
I am not taking.
Acha,
Yeah, personally, I'm not taking, but yeah, there will be instructors definitely.
there will be instructors like how this qualifier you are helping, like that it will be instructors.
Yeah, there should be the same case. I mean, there should be same instructors. Some.
Okay, okay,
Yeah,
okay.
you can also verify it with another courses. I mean, you are also joining another courses, right? So you can also ask them about it. I guess
Acha.
they.
Okay, okay, okay. Is there any chance to meet directly and get it clarified, madam? No.
Yeah, like if you can come to the campus, you can definitely meet directly.
No, definitely no. I asked them, but they told that it is not allowed. for other peoples to come in.
So you don't have any ID card?
No.
Okay.
Madam,
So
actually, there are two process. Like from foundation to BS is the one process. The other process is directly into the diploma, where the curriculum is something different. Week 1 to week 4 will be in one stitch.
okay.
Week 1 to week 8. Sorry, week 1 to week 8 will be in one stitch.
Okay.
It is something like that, and week 1 to week 4 will be the qualified exam, but it is little vigorous. It is
Yeah,
not.
yeah.
It is not. It is
That
not
time.
same as qualifier foundation. The topics and the examination point of view is different. But I just want to know whether the instructor will be there or not. That's it.
Instructor are there for all the courses, whatever I know. Like personally, I will not be there, but another instructors will be there definitely.
Yes, and you have helped a lot of students, madam, and you are teaching, not to praise, but some of them, one of my colleagues have passed an exam because they told me that you are a very, very good, person to help people in teaching alone. So that only I asked you. Yes, madam, I will check with other persons. Anyways, thanks.
Yeah. You can reconfirm it with other person. Because
Acha.
whatever I know, there should be other instructors, but it's always better to reconfirm. But I'm not very sure, but there should be instructors for all the courses.
Okay, madam. Thank you.
Yeah.